So we're going to look at a few things about switch features. We're going to look at some of the clocking options in Dante. We're going to look at latency in networks. And we're going to look at how we put audio channels into IP streams and whether they're unicast or multicast streams. And we're going to look at a different sheet. We can create backup devices by exploiting the fact that we use naming to route audio around. We're going to look at Dante redundancy. We're going to look a bit more at Dante Virtual Sound Card and also at Dante VIA. So we talked this morning about managed versus unmanaged switches. Partly a recap. Managed switches are generally more expensive. There are many, many more possible settings on them and risks. And of course, you get lots of consultants telling you that you must do this thing with a managed switch, which sometimes doesn't work out for the best. And then people misunderstand features that switches have. My favorite one at the moment, people have heard this thing that, oh, Dante uses PTP. Oh, I need a switch with PTP on it. You don't. Okay? In fact, I've had this conversation probably 3 times a week for the last 4 weeks with different people. Like anything, yeah? You've just had a demonstration of loudspeakers. All of us, when we're looking at a new technology, get the data sheets, look at the numbers, work out what those numbers mean. Because it's very rare that a switch will improve clocking scale over what we already implement. So, seriously, then you have to interpret data sheets. So we talked this morning about jitter being a spectral thing rather than just an absolute number. That absolute number tells me nothing, really. So I need to look in detail at these things and actually make some informed decisions. So managed switches will give you all kinds of data, tell you all the wonderful standards they implement. Typically, if you look at a managed switch data sheet, you'll see about 700 standards it implements. What do they all mean? Well, you could go and read all of the standards if you like. But really, yeah, very rarely does a managed switch actually give massive advantages for most normal audio networks. You may need it in enterprise, but then hopefully, if you're going into a mixed traffic network, you can just slot in with the IT department. I spend a lot of my time talking to enterprise IT guys. I can give them a very basic profile of what Dante is. They go, okay, yeah, fine, that's great. We could just accommodate this. Yeah, they're supposed to be the network engineers. We're supposed to be the sound engineers. Supposed to be. I end up doing a lot of network engineering, don't worry. But in general, if you can start with giving people a sensible profile, allow them to at least make an effort to do their job, it helps. Unmanaged switches generally a lot less expensive, 100% plug and play. They may not be appropriate in some situations, but I have a big stock of these very cheap unmanaged switches for just setting up lab tests in my office. For most things, I just want to work fast on testing a software feature. I don't particularly want to get involved in rejigging the switch every time. And luckily with Dante, I don't really have to. So, just to reiterate from this morning, if you use one switch to connect your Dante devices and you're only using the network for Dante audio, then you don't need a managed network switch. Please, yes?
Can you share some example of where we can use managed and unmanaged switches?
That's a very broad question. If you give me an example of the application you want to build, I'll probably help you better. I think that is on a case-by-case basis. I'm not going to make any apologies for it. Networking is not simple. Okay? Networking is by definition complex. So it's misleading to tell people that under these circumstances you must do things. This is a mistake time and time again that manufacturers have fallen into. You may see special network switches coming from audio equipment manufacturers, where just press the go button, it does Dante now. Until you get to a certain size or you try to do something they didn't think you were going to do. Okay, so I've been immersed in doing networking. I've been involved in audio networking now since, not too long, 1996. So I've been doing it 23 years now. So I have quite a lot of experience in it. And my experience tells me not to give an example. I'm sorry. If you tell me what you want to do, I'll give you some guidance. I'm very happy to do that. Okay, that's by far the wisest way to do these things.
So just to give you an example, it's like a facility with multiple
Okay.
rooms,
Yeah.
right, pre-wired already.
Okay.
And of course, you know, when they're pre-wired, nobody really thought about network audio and stuff
Sure.
like that. So the IT boys have gone and done their bit, and they could have bring it all back in the control room with some managed switches. So you're kind of inheriting that infrastructure.
Maybe. But remember, you just said it's pre-wired building. One of the things with pre-wired building is just like any other wiring infrastructure, you have cables going back to a patch bay that then patch into the switch. I've done this in my office building. Our network guy for the overall building is completely incompetent. He's terrible. I got him fired. Then I got him rehired because it was complicated. But he managed to compromise the network of our local member of parliament. So I could see broadcast traffic on her network. I could log in using her gateway and pretend to be her. He wants firing for that, right? That's just bad IT. I don't want him doing that to me. So I went to the building and said, look, this is not going on, okay? I'm putting my own switch down in the comms room. I'm taking my own cables from my wall boxes. They're going in my switch, and I'm in charge of where they go now. You're not touching those things. In a pre-wired building, you can do that.
Say a legacy room, it's just really, somebody just dropped literally one cable into the room, thinking, hey, you know, one day we might need it. But that's the only one cable, and we don't really have the ability to pull more cables. And now that's the only one physical cable.
Yeah, but it has to go somewhere,
Right.
and you can unplug it from something and put it into your own infrastructure if you wish. Or you have a debate with the IT department, hopefully they know what they're doing, and maybe they give you your own VLAN through that network. Okay, that would be a function of a managed switch, but as far as you're concerned, you're not maintaining the VLAN. That's an internal VLAN for them. You don't care about that. All you want are your untagged packets in and your untagged packets out. So you don't need to get involved with the managed switch there. As long as they just give you transparency on that, yeah, fine. And that's in practice what we do all the time with IT colleagues, yeah? We just want transparency. We want to know that our stuff's going in untagged, our stuff comes out untagged. And just like on stage, if someone's got a bad cable, the front of house guy doesn't want to know. It's not his problem. It's someone else's job. Yeah.
Do we have any bearing on that?
Well, so this is one of the things that comes up occasionally. Let's go right back to the first principles of what Ethernet and category wiring is. So one of the really cool things about Cat5, Cat6 interfaces and the RJ45 interface is it's a transformer isolated interface. So you have the cable is effectively completely floating. Okay, you can have shielded cable and all that kind of stuff. And what you'll find is people say you have to have shielded cabling. Mainly that's so they can pass CE testing with the electrostatic discharge test. By the way, that's why the Ethercon exists. It's brilliant for manufacturers. If I plug the Ethercon in to do my ESD test, I can't get the probe anywhere near the pins, and I pass by default. It's brilliant. That's why it exists. Okay, so that's really easy. So we've got a floating connector. What power over Ethernet is DC. Now, I'm sure everybody knows from basic electronics that DC can't go through a transformer. So what we do is we put our DC power over Ethernet onto the cable after the data transformer, and we pick it off at the other end before it goes through the data transformer. So PoE on the cable, if I'm not receiving PoE, it's just a floating voltage, it's not a problem. Yeah, so that it can't dissipate any current because hopefully no current can flow. You'll fail CE testing if you do that, so if the current flows, so don't worry, that shouldn't happen. So in general, no, power over Ethernet doesn't have an impact. Those devices use power over Ethernet. It's absolutely essential to them, so yeah, it's very handy. And of course now you can get power over Ethernet speakers. So you can get quite a lot of current down a PoE cable. It gets a bit warm. And lots of people are putting gigantic capacitors inside the speakers to smooth it out. Unless you're playing really, really nasty music, the cap always has a chance to replenish itself. So for speech, it's ideal because speech is highly dynamic.
Supposing we have an option of turning it off or turning it up, so we don't care.
Well, don't worry about it. Yeah.
Please don't wire the cable wrong and blow up something.
Even if you wire the cable up wrong, you might blow up the driving circuit. Unlikely. But you wouldn't affect the endpoint gear. If it wasn't PoE, you'd be okay. Yes.
Can Dante controller use Wi-Fi?
Yes, absolutely. Yes, it can. So some feature recommendations for switches, some very basic ones. Generally, one of the things that, to your point earlier, where people want examples, well, everybody panics. They go, oh, I've got to tell these people these things. Okay, so I'm going to tell you all of the magic buttons I can hit that Dante implements. Right. Best thing to do, take the switch out of the box, plug in your network. If it works, fantastic. Get paid. Yeah. The problem with this over-configuration, this is the most common fault I find where people have over-configured and configured wrong, is they've followed some guide or other which had one specific application in mind and it's completely inappropriate. So normally I would say, and this is why I'll give some contradicting examples. There we go. This is how you make your own mind up. Normally I would say the most important thing that you can do is protect against multicast in the network before anything else. You don't want unwanted traffic going all over the place. Okay, that's in 99% of networks, that's absolutely true. And if we can reduce the amount of traffic going to stupid places, then we have plenty of bandwidth available for the rest of the network. Problem solved, go home. There's something called quality of service, which we use to extend functionality into areas of reduced bandwidth. Hey, we were just talking about bandwidth. If we're sending stupid data everywhere, wasting bandwidth, the best thing we can do is stop wasting bandwidth. Then we don't need quality of service because it's not creating that problem. Now, so IGMP snooping, which manages multicast first, fantastic. Then very unlikely that you will need it for audio quality of service. Yeah, but you can. Most of the time it doesn't matter. However, I'm working on a project at the moment where they're sending hundreds of channels of multicast and every single device in the network has to get the same channels. So strangely, quality of service is much more important than multicast management. Now, that's the only time I've ever seen an example like that, because they're trying to run some very, very high resolution control on the same network. So now all of a sudden, just in case, because of the sheer number of devices, I want to stop that control traffic whacking the audio. So quality of service is more important than multicast management. So it's never, this is right, this is wrong. Those are two extremes. And what you're going to be doing somewhere in the middle, or probably off here where it doesn't really matter so much. I mean, remember, I was talking to a gentleman who is very senior at Cisco, and he said he was looking at what we were doing. He said, oh, so you're doing quality of service management. Oh, that's very polite of you. Why do you need it? What do you mean? He goes, well, we're doing uncompressed video on these networks at 12 gigabits per second. Yeah, maybe that matters. How much bandwidth does four channels of Dante take up? So, well, 6 megabits per second. So, they're sending a little bit more data than we are, about 2,000 times more data per channel. So, to be fair to him, and he said, he goes, you know, with all due respect, what you're doing, you're a rounding error. Yeah, audio is a rounding error when compared to video. So if you've got a quality of service problem, it's going to be caused by the video, and whatever you do to the audio is going to make no difference. You're basically in trouble. The best idea when you have a problem with bandwidth is buy more. You know, it's the answer nobody wants to hear, but it's the one that will work. To this end, don't change the settings on the switch until you realise there's a problem that you can help with. Like I said earlier, we had people talking about wanting to set quality of service between the console and the stage box. It's completely ridiculous. In fact, turning it on makes the network perform less well. So yeah, basically start simple, start with the default features, see if it works. It probably will. And resist the temptation to over-configure. This is the thing that people get into most trouble with. If you let the IT department do it, there are a few key things that normally get missed, and it's easy to go through There's stuff in the level 3 course about just giving this one piece of paper. We publish it online as well. That should be adequate to make anything work. In most standalone Dante networks, you just don't need any network control features at all. And yeah, incorrect switch configurations. Basically, over-configuration, seriously, from supporting this as well. Over-configuration is normally a lot more of a problem than not turning features on. I'm trying to think of an occurrence where I think I've had one case where turning quality of service on really was actually the solution in nearly 10 years of supporting this worldwide. I can tell you about 3 more cases where turning quality of service on masked a bug that we subsequently fixed, but so I can only think of one place where we actually needed it as necessary. Oh, everybody's favourite subject, clocking. Because when there's nothing else to talk about, we can always debate clocking, can't we? So how does the clocking mechanism work? Well, we use a protocol called IEEE 1588 PTP. And of course, like all things in networking, there are multiple versions of this. The level 3 course goes into the detail of how PTP works. So if you're really that interested. In the level 3 course, we talk about the mechanisms of both versions because they're functionally identical. They have the same resolution. Okay? There are some tiny variances between version 1 and version 2, but in terms of what we're doing, it's not an improvement for audio. We did get phoned up by CERN, the people with the Large Hadron Collider. They want to talk to us about timing. Yeah, I'm sure that would work, but anyway, it was very interesting. So yeah, we've done a bit about timing, and it's all about syncing devices to a master clock. There's lots of stuff in the standard about electing a master clock. Each of the devices has its own clock, and it's a resilient structure. So basically, any device can become the master clock, and there are all these criteria about, there's mathematical equations inside the standard to work out whether your clock is better than the other clocks, which are part of that negotiation process. So if you leave it to work automatically, it's actually going to find the best clock device for you because that's all defined. If you want to mess with it, you can do that. Beware of people giving you classes on PTP, okay? Simply put, if you want to buy both copies of the standard, it's going to set you back about $800 for the documentation. How many sales guys are going to spend $800 on a book, which is about 1,000 pages long, let alone understand it? So, yeah, a lot of stuff. Just feel free to go in the IEEE library and get yourself a copy. It's actually reasonably well written. Yeah, I have actually read it. Well, both versions. And it's not one of those awful standards that go, oh, no. It doesn't make you fall asleep. It's actually okay to understand. You have to skip around a bit. It's one of those things that cross-references 200 pages later. But no document is ever perfect. So what we do with Clockmasters, there's a very prescribed election process in PTP. And if we want to set up an audio system, we can rig the election. Because there are circumstances where we might want a static master clock. If we're dealing with something like synchronizing with SDI video, for example, we need to synchronize black and burst with audio word clock. Totally fine. And we'd want to do that at known points in the network because we don't want to go running around with the sync cable around the site as the clockmaster changes. That would not be much fun. So there are real human physical circumstances why we might want to have a specific master clock device. But in terms of the theory and of how the protocol actually works, that's kind of outside it. So, in Dante Controller, we have 2 columns. We have a preferred master column, and we have an enable sync to external column. And by using a combination of these, we can force the master clock to be in a certain place. So if we go into the clock status screen, which you can just about see here, we have different selectors here. So if the device doesn't have an external master clock, obviously you can't select that. That would be silly. But if it does, if it has a BNC input, we can select that, and we can also make it the preferred device, and we can see here it's become the master clock device here. And if it has a valid external clock source coming in, it will start timing here. So in terms of the clock election process by default in Dante, if a device is selected as preferred master, it should win. If it's not selected as preferred master, but it's selected as enable sync to external, it will win the election process. And then if nothing's checked, we'll go into the iterative algorithm where we look at clock quality of devices, and then we also look at, if they're all the same, we look at who's got the lowest value MAC address, or more correctly, clock ID. But the clock ID in PTP is 64 bits long, and the last 48 bits are, you've guessed it, the MAC address. So yeah, but really it's the MAC address that decides it. And that's not a bad criteria. Basically, what we assume, and we use lowest value MAC address elections for things like spanning tree in networks all the time, it's because the assumption is, if I have a lower value MAC address, that device is probably going to be older. And because we assume that networks grow outwards, that means that the older device is near the middle, and that means they have the shortest path around the network. So if you're being a master device for something, being in the middle is a really good thing to be. So that's why it's there. Now, of course, in a Turing system or a brand new install, everything's jumbled up. There's no way of telling who's got the lowest MAC address. I certainly wouldn't make decision criteria about where I place equipment based on its MAC address. Life is just too short for that. So you could use the preferred master under this circumstance. That might be another way to bring your clock towards the middle. So, like I said, Dante will always elect a clock master regardless. And if you change the clock master, there won't be any effect on the audio as the devices follow the new thing. That's basically because we're distributing time. So the master clock reads out what the time is, all of the slave clocks take note of that, and they set their clocks to the same time, and then everybody gets along with the business of generating that local media clock. So because everybody knows pretty accurately what the time is relative to everybody else, if the master clock dies, everybody's like, okay, I'm just waiting for that signal, but I've got my own watch here that's pretty good. I know what the time is. Oh, right, new master's come on. Oh, I'm not that far out. No problem. Carry on making sound. So it's not like a serial synchronous system where if you pull out the clock cable, everything goes drifting and everything goes wrong very quickly. In fact, I knew a system at a radio station that lost its master clock because the IT guys changed a setting. They blocked the multicast, and it was in an air-conditioned data center. Those clocks went into free run, and free ran accurately enough for 2.5 days before they started dropping audio. So yeah, basically you switch masters, you've got 2.5 days to sort it out in an air-conditioned room. If you have a temperature gradient, hey, your time's a lot shorter, but there's still plenty of time to elect a new master and carry on. If they had Dante Domain Manager, of course, it would have told them straight away, and they would have never lost audio because they would have had time to fix the thing. Dante Domain Manager is great for that kind of thing. If you're going to put a preferred master in, make sure it's a device that's always present in the system. That makes sense. You don't want to have random relocks of things going on. That'd be crazy. There is a non-standard algorithm we run based upon age of clock. So if a new guy joins, we will ignore it and tell it to shut up. This is because PTP has a day and date stamp in it. So Dante devices, to make this work, always start from the beginning of known time. And anybody working in computing knows the beginning of time was the 1st of January 1970. They always start up at that date. So if things are significantly older than that time, or significantly younger than that time, they move forwards in time. Then we know that new guy who's just started up, probably someone on the edge. Let's ignore them. So that's a non-standard thing that we do with Dante for Dante-only systems to protect them. Using an external clock, we can enable sync to external, and what that does is instead of the device listening to the clock oscillator being driven by PTP, it now listens to an external, say, word clock at 48 kilohertz. That runs the media clock for that device, and then that also runs the timer, which can, if you make it the master, is played out. If you don't make that the device the master, and you drive a different clock for the rest of the network, the audio will be out of sync. So be careful about turning on external word clock without making it the master. Now, if you can guarantee the synchronization of your serial word clock and you want to put multiple devices enslaved to external word clock, now we're dealing with theory, now we're dealing with entropy, okay? Could you guarantee that two independent oscillators are going to stay locked forever, even though they're running at the same frequency? They should, but kind of, I have found empirically that that's not always the case. And when you're in an arena with 24,000 people and the left and the right side of the PA are doing this, it's a bit embarrassing and you want to turn on those clocks off. But it should work, okay? And people have had success with it. Just to make sure, you have to configure the clock source in the consoles as well. This is something people miss. In a Yamaha console, say, we can sync to Dante, or we can sync to the word clock in. If we select that, we then have to make the Dante device slave to this external word clock and make it the master so that everything else is synchronous with this. If you then make another console slave to its internal oscillator, it will be completely out of time with the Dante network and you'll just lose the audio. Mismatches in clocks very rarely anymore result in pops and clicks. Generally, most devices will just go into mute. You might get a mute-unmute event, but you know, we may have heard crackles and pops on older systems that don't assert a mute when the clock goes out of whack. But generally doesn't happen so much anymore with the way people implement devices these days. You can use active clock monitoring in Dante Controller to keep an eye on the quality of the clock going on in your system at all times. So if you're using an external clock, make sure you've configured the clock, make sure you've configured the devices, make sure you've told the Dante network where the joining points of those two clock domains is so it knows where to follow it from. So just go through those steps. And this is just general stuff from general clocking practices. What we found is a lot of people have found their first experience of connecting multiple digital audio devices together has been with Dante. I used to do a lot of work with MADI, used to do a lot of work with AES3, ADAS even. So this kind of clock discipline thing is stuff that I've been doing for a long time as well as doing it on the network. So the rules, if you've been using those older systems, aren't really any different. It's generally the same kind of process. Always check the preferred master on devices that are using slave to external word clock. You can have multiple devices that check as preferred master. All that means is that the one with the lowest value MAC address will win. But if they've both got that external word clock hooked up to them, that should be okay. And if then one of them dies, the other one will take over and still win the election because it has preferred ticked.
If two devices have same smallest MAC address, then
if two devices have the same MAC address, that means someone has gone and ripped off a Dante module, and you should go and find the factory that did it and beat them up, because MAC addresses are universally unique. Yeah, we paid lots of money for them. Yeah, you basically buy a block of MAC addresses off the IEEE, and the deal is that they're all unique in the network. So clock status monitoring. In passive, it's always on. It will only tell you about changes, who's changed the master clock, etc. You can pull up a clock histogram and tell you what the offset is from the master frequency. And this kind of spread is absolutely fine. This is parts per million. Typically, most manufacturers will set a mute at about plus or minus 200 parts per billion. To turn active clock on, we have this active clock monitoring rather. We can turn this on in the toolbar in Dante Controller. It's useful for checking logs on external clocks. It will tell you whether a clock has gone bad or not. Basically, it will log time, data over time, and you can have a look at multiple things about clock spreads. So a little bit more about latency. So we talked about latency being a delay in transport and processing, and mainly a problem we hear when we hear undelayed and delayed sound simultaneously. So just think, in air, sound travels at about 34 centimeters a second, which is round about a millisecond. So that's about 1 foot in old money. And, I'm, 6 feet tall. If I've got a monitor wedge, it's travelling 5.5 milliseconds before the sound hits my ears. So that's already 5.5 milliseconds latency. And I don't mind monitor wedges too much, they're okay. If I'm doing my Stadium Rock guitar gig I do at the weekends, and I'm 24 metres away from my guitar cabinet, that's about 70 milliseconds latency. Okay, you can definitely hear that as an echo, but hey, most guitarists don't mind, they've got it turned up loud. One of the funniest things that we have, when you go to these AES conventions, have you ever seen the organ recitals? Yeah? Why do we pick the instrument with the worst latency performance in the known universe for these things, yeah? Of a church organ, yeah? The pipes are miles away from you. Any professional organist you meet isn't listening to the organ. If they do, they're dead. They'll be out of time with themselves. All organists I know put their fingers in their ears, or something in their ears, and go and just ignore it and just bash away, because what's coming out is complete nonsense. As long as their fingers are in time, yeah, they'll be okay. So yeah, there are some instruments with incredible latency. I was a professional French horn player, and the latency between here and the end of the instrument is 14 milliseconds. It's that long. But it's still playing time. Oh, you get sacked if you don't. There you go. So, yeah, this kind of microscopic latency, people can hear, yeah, you'll hear it as a phase shift, of course, but actually hearing it's an echo and it being a major problem. The major problem with latency is generally if the latency keeps changing, because that's really distracting. If it's constant latency, your brain can work around it quite well. So, setting and monitoring latency. We looked earlier about the device config screen in Dante Controller, and how we can set the latency of the devices using these different boxes. In the new version, it's a drop-down menu because there are more options. And we can monitor the latency in the Latency tab. This is probably the most valuable tool for diagnosing networks that you could possibly have. So before you go and reach for your network configuration stuff, and this is something I was talking to guys about earlier, this is what I recommend to absolutely everybody. Open up the latency monitor, well, after you've set the latency up. So by default, everything comes out as 1 millisecond. Generally, you can look at different numbers of switches and make an approximation on latency. This is our kind of dial in the distance guess idea, ignoring temperature acoustically. These are absolute worst case scenarios. The best way to do things is to just measure it. And the way we measure it is in Dante Controller, we can pull up the latency view and it will tell us how long it's taking packets to get from the source to destination. On a real-time view, it tells us how long the longest latency's been, what the average is, and if any packets have arrived late. So this has been successful in lots of places. I was working with a sports broadcaster in quite a small country, and they were saying, well, we'd really love to be able to connect all of the stadiums together with Dante. So that's pretty cool. This sports broadcaster happens to be owned by the National Telephone Network as well, which is quite convenient. So what we did was they went around the country with a copy of Dante Via on a laptop, plugged it into the network, went back to the TV centre, played some music over it, looked at the latency view, and if there's no music coming out and all the packets are late, it's either the wire's too long or there's something in the network slowing things down. Or if it's just slightly late, you can turn your latency setting up to compensate for it, and then the packets will arrive on time. So using this view is the most valuable network troubleshooting tool. In fact, because these guys were owned by a telecoms operator, they said, well, hang on a minute. If we bought a test tool to do this, it would cost us many hundreds of thousands of dollars, and you're just giving it away. Because we're taking microsecond timing accuracies across the network here, and we're able to do it on a per packet basis. This is a really powerful network test tool. Just because it happens to play nice audio at the same time, that's a bonus. But it's really, really good for validating networks. The problem with doing a ping, which people are keen on, yeah? Ping gives you the round trip time. It gives you the round trip time from your operating system to the remote site and back again. But it has to go through the remote site's operating system. So if someone's playing a particularly intense computer game, that ping function is going to get deprecated really, really low. So it's not telling you about the network time as much as it's telling you about how slow the computer is on the other end. Whereas what this is doing is it's measuring the time between the transmitter and the receiver. So it's a really, really deadly accurate measurement of latency. So it's really cool for doing all kinds of measurements. I would always suggest trying to lower the value of the latency. When you've got a nice clean spread like this and you're set at 1 millisecond, you could drop it down to 500 microseconds. Now, you're going, well, don't be stupid, because it says your peak value is 645 microseconds here. If you set it down to 500 microseconds, some of your packets are going to be late. And that would seem fairly rational. What actually happens with Dante is that when you drop the latency, Dante will automatically reprofile the flow of packets, and it will put fewer samples into a packet before it sends it. So the thing that takes the longest in an audio network is actually accruing the samples, if you think about it. So a sample, as I said earlier, is 21 microseconds at 48 kilohertz. So if I want to take 4 samples, that's 80 microseconds. And a maximum transmission unit frame of 1500 bytes will take 12 microseconds to go through a gigabit Ethernet port. So actually, the thing that causes the latency in audio networks is waiting for the data to show up in the first place. Encapsulating it and transmitting it takes no time. So the actual sample collection is the thing. If we turn the latency down, we just collect fewer samples before we send. Okay, we're sending more packets per second. So that means if we're going through an IP router, it has to do more work. But if we're in a local area network, it's not such a problem. So yeah, always try dropping the latency and see what happens if you're in a test scenario. I wouldn't recommend doing it if you're live to air. So here we've got a situation where we're getting close to the edge. So we've got 250 microseconds. And okay, this has arrived in time, but it goes amber, saying, oh, be a bit careful, you're getting close to the edge of the window. Solutions, we could increase the latency. Because this is widely spread on this, I would say you could try something like quality of service here. If you do get these big gappy spreads, that would indicate jitter in the network, so indeterminate timing. If you have a small variance or a linear variance in your latency, quality of service is going to be less significant. But if you have a big variance like this, that suggests you've got indeterminate timing, and quality of service may help you there. And it could be just plain old faulty equipment. You could have a dodgy cable. That's happened to me enough times. In fact, dodgy cables are the things that cause problems still. We never got rid of those with networking, I'm afraid, sorry. So, we put information into what we call flows, which is, could be called a stream or a bundle in the old days, maybe. And we can send Unicast, which is a one-to-one traffic relationship. It's like having a private conversation between two devices across the network. The receiver asks the transmitter for a channel, and the transmitter sends the channel to the receiver. And of course, if we have multiple receivers like this, they each have their own individual transaction with the transmitter. So we actually use up a lot more bandwidth from the transmission side. By contrast, we have multicast, and in an unmanaged network, the concept of multicast is one-to-many traffic. So my transmitter sends one packet into the network, a bit like a TV broadcast, yeah? Now, that's why the relationship is slightly different. If I make a telephone call to somebody, I can tell very quickly if they're not listening or if they've hung up. If I'm making a TV program, I'm basically putting my television program into the air, and I hope people are watching, but I don't know. And that's exactly the same with multicast transmission. We send packets into the network and we kind of hope people are listening, but they might not be. It's like a public announcement. They go out across the network, and if we don't manage multicast on our network, that multicast traffic will go absolutely everywhere. So this means the data is received at every node, and they have to get rid of the traffic they don't want as early as possible. So it creates processor load all over the network. So here's it pictorially. I've got 3 different receivers in Unicast. I send 3 packets from the sender. In multicast, we just send 1 data stream, and the switch splits it out to all of the receivers. So in a managed switch, we can turn on a feature called IGMP snooping, and this makes sure that only paths through the network where people actually want to listen to that multicast are connected, and everybody else is left quiet. It's the most valuable switch management feature, in my opinion. Organisation of multicast receiving groups is done within a managed switch. So we just turn, typically in most switch vendor applications, we just turn on IGMP snooping, and that's all we need to do, and it will set up everything else. We actually go into how IGMP works as a protocol in the level 3 course. It's separated into a separate YouTube video if you guys want to watch that. It explains about everything about that. But we can also get rid of multicast from services that we're not interested in. So if we had, say, some kind of IP security camera system that's already existing that's non-Dante, we could just put that into a different VLAN, and its multicast all goes away. It's not our problem. So we can also have our own Dante stuff in its own VLAN to stop its multicast interfering with other people. So there's many different techniques for making sure networks are separated, because as much as networks are about joining things together, they're about breaking up different services into where they're needed. And that's the real art of networking. So Unicast flow, we always put the content of 4 audio channels into a Unicast flow. And if we've only got 1 channel going, the other 3 channels will just be empty, but we still use up all of the bandwidth of 6 megabits per second. In Unicast, the flows are unique to each receiver, so there'll be an individual relationship between the receiver and the transmitter. And yes, the flows may contain empty audio channels. But if all of a sudden we decide to send, say, channel 2 from the stage box to the same mixing console that had channel 1, because it's Unicast and there's a relationship between those 2 points, we can just put the audio from channel 2 into that spare slot in that existing flow, and that just happens very rapidly because it's just a DSP function, and audio starts to flow and there's no change to the bandwidth. So it's really cool like that. So here's some worked examples. More receivers means we have more flows. So here, maybe we're sending some channels to our monitor amplifiers. 8 channels is 2 Unicast flows. So we send 4 channels at a time. We're using 8 channels here, so that's 2 flows. Of course, we have different flow capabilities per device. So small Dante devices, the little 1 to 4 channel ones, they can send 2 flows. Larger devices, so the virtual sound card, can send 16 flows. The Brooklyn modules that you find in mixing consoles and those kind of interface cards can do up to 32 flows. And then the very large devices can do 128 flows. So let's compare Unicast and multicast. I'm sending 8 channels to each of these amplifiers, the same 8 channels. That means I'm going to use 2 flows per amplifier, which means a total of 4 flows. And then when I start to send to more, I'm going to be using 8 flows to send to these 4 amplifiers, even though I'm sending identical audio. Dante Controller will warn you about fan-out detection here because it sees you going to 3 or more different destinations. It shows it as a warning. In general, in a fixed installation environment, if I'm driving amplifiers, it's probably a good thing to look at. But there are certain circumstances where this fan-out thing is to be ignored. So, say I'm working on a big sports broadcast, Wimbledon Tennis Club, yeah? They have 21 guest broadcast suites, and so it might be quite handy if I've got stage box. I might want to send Unicast to each one of those different guest suites because they might want to set their own latency for their own systems. In which case, I would use a 32 flow capable box, and I would use the smallest thing possible to send that. So there are certain people who have built like even a 4-channel commentary box, which can do 32 flows. It means they can hit 32 guest suites Unicast before they have to worry about multicasting. So sometimes if you're designing one of these things where you want to have lots and lots and lots of Unicast splits, go for the smaller stage boxes, the 8-channel ones, but with the 64-channel capable card. You're going to get a lot more ways to split than the 64-channel card, which has only got 32 flows still. So your numbers of splits have dropped there. So, it's a design consideration. I like it because we can sell more cards because you can do more splits. And the manufacturers like it because you have to buy more tin boxes. But sometimes, seriously, it is a real design consideration for those kind of installations. So with multicast flows, because it's like a television broadcast, yeah, we just send it out there. We send multicast with 1 millisecond latency. You can't change it because it's just a packet that gets duplicated everywhere in the network. But the benefit here is we can send 8 audio channels in a single multicast flow. And now we're only sending 1 flow and hitting all of these amplifiers. And that's how, if we're doing a big stadium where we have maybe, there's one I worked on that had 192 amplifiers, we only sent 1 flow out. We're actually only using 12 megabits per second on this network to drive all of these amplifiers. Because amplifiers in a stadium generally want the same audio content. It's a bit weird if it's really different, especially if you're doing the DSP processing at the amplifier end. And we can configure this in Dante Controller. So setting up multicast flows, we open the device view and we hit the Create Multicast Flow button, which looks like this. And then we can choose up to 8 channels to put into a multicast flow and hit Create, which looks like this here. So one trick is to remember, because this is a fixed TV broadcast, it's not renegotiated. Once you hit that Create button, that's it. You can't add channels to that flow. If you want to add channels to that flow, you have to destroy it and then recreate it, and that's going to cause a problem with your audio. Don't worry, in Dante Controller, it always puts a warning message on the screen if you're about to do something that could interrupt the audio. Okay, so my top tip on this is, because the bandwidth utilization is so small, relatively, generally don't send single channel multicast flows, generally. And I'll come back straight away with an example of why you would. So if I'm doing a big shopping centre and I have a fireman's microphone, that's a 1-channel multicast flow right there. But in general, if I'm feeding, say, loudspeaker information, I can put my left, my right, my sub information on 2 channels into a single multicast flow, and I can send that everywhere, and everything's good. Save me rewriting overheads. And 1 millisecond latency for amplifier distribution in the stadium, it's fine. So do I need to control multicast? Well, on a gigabit network, multicast traffic is unlikely to be a huge problem in normal circumstances. Of course, there are circumstances where there may be a lot of multicast. So remember that 64 channels of multicast is still only going to be about 100 megabits per second of data. So if everything's gigabit, still only about 10%. I would say 100 megabits per second of multicast would be considered quite large by most network managers. But if it's a Dante-only network, it's not going to make much difference. If you don't want to go and mess around and try and work out multicast management, don't worry about it. You're probably quite safe. But if you're using 100 megabit per second devices, like the little AVIO adapters, 100 megabits per second of multicast will be a serious problem. So using multicast management then may be more helpful. And of course, if you have a Wi-Fi access point, you need to be protecting that from multicast, because you may as well not have it. It's just going to be spewing multicast out, and you'll get no other connectivity through the Wi-Fi access point. Which is why IGMP snooping is a good idea. Just use multicast as selectively as possible. That's the best practice here. So in summary, we use Unicast by default. So whenever you create those subscriptions, that's always going to be Unicast relationship. Every time we have a relationship, it's packaged into multi-channel audio flows. And the number of flows is limited on devices because of the number of packets it can generate. So the tiny little AVIOs can only do 2 flows, but one of those flows could be a multicast flow, so they could get to everywhere. And we can do 32 flow devices. Now we have 128 flow devices as well. Remember that each receiver requires at least 1 flow, and unmanaged multicast is flooded all throughout the network. You need to maybe use IGMP snooping to manage that if you're dealing with a lot of multicast. But multicast is very useful for conserving the number of flows you're using. A Dante device doesn't care whether it's a unicast flow or a multicast flow, because all it's doing is changing its destination IP address. Explicit management of multicast is often not necessary in smaller networks. It's only when things start to get big and mixed use and trying to put Wi-Fi in that it begins to matter. So some tricks with naming devices. We looked earlier at how we name devices in the level 1 course and how we name channels. We name devices to make systems easy to understand, and of course channel labels can help in very busy environments, and of course, like I said, name things first, then do the routing, then add the next box. So we looked at the transmit tab, and you just enter the channel label in Dante controller like that. And again, comments about masking tape. But we can do a trick. We can create backup devices using the same name. So we use names to create subscriptions. So we could do this as a trick. You could have, say, 2 stage boxes. One's the main one and one's the spare. If you name them the same and take one offline, then if the first one dies, you can plug the second one in and everything receiving will think it's the same thing. Be careful doing this if you're going to, because if 2 devices have the same name and they're active at the same time, Dante will automatically rename the second one and make it red, and you have to fix it. So yeah, if you're going to do this trick, make sure they never ever are active on the network at the same time. In fact, if anyone's used QSC devices, their redundant core method names the Dante cards the same and holds the second redundant core in reset. And if the primary core dies, it flips up, and all the receiving devices think it's the same thing. They've actually implemented that. It's very cool. So, basic security. This is not to the same extent that we're doing with Domain Manager, which uses enterprise-grade encryption. For small networks where we're working in, say, live sound or a small broadcast installation, we've got this device lock feature. So it prevents tampering with Dante devices and settings. You need to have Dante Controller 3.10 and also the firmware update on hardware devices. It's also supported Dante Virtual Sound Card and also in Dante VIA, and it will only affect devices seen through Dante Controller. So that means if I'm doing routing on a mixing console and the mixing console is doing that routing, it's not subject to that device lock because it's got a different way of connecting. So to enable device lock, double click on the device and press the padlock item like this, and then you can type in a PIN number and confirm it, and that device is then locked. That means someone can't come along and accidentally change your settings. And then simply to unlock it is the reverse. You'll see here that the relationship show up red here instead now because you can't change them because the device is locked, and you have this little lock icon next to them. So of course, for the maximum security, you lock the receiver and the transmitter, so no one can mess with either end. And of course, attempt to change routes mean that nothing will happen. And it will also limit the number of flows used by the transmitters. To unlock a device, again, double click on it, click the lock icon, and then put the correct pin in. And of course, I used to work for a rental company, and we all know what happens when people put in a password and forget it. I think the worst instance was we got this brand new desk. The engineer had used it. It came back to the workshop. He'd gone home for a break, and home for him was Christchurch, New Zealand, which is about as far away from the UK as you can get. And we got this desk and it's locked. It's got a password on it. He's in the air. Right. Okay, so what are our choices? Well, in this particular case, we rang up the manufacturer and they told us the master password. Problem with master passwords is if they exist and the manufacturer tells someone, within about 5 minutes everybody knows the master password. So that doesn't work. So we chose to do something slightly different. If you forget your PIN on a Dante device, you have to unplug the device from the network, plug it into your laptop directly for about 6 minutes, and then when it's done that 6 minutes, it goes into a state where you can release the PIN number. This is based on the assumption that if you're missing audio from a critical device for 6 minutes, someone's probably going to notice quite a lot. But, it's a compromise between, completely bricking the device or having a master password, which is inherently insecure anyway. Let's face it, with PIN numbers, most people use 1, 2, 3, 4 anyway, don't they? Yeah, it's only for that single device. You have to do it one device at a time. So it makes people resist the temptation just to unplug things randomly, because you can't do it en bloc. You have to do it one at a time. It takes, if you accidentally lock up 10 devices, that's an hour of your time that's just gone. Maybe if the person knows the PIN number and they've run away, maybe that hour would be better spent trying to find them. So using device lock in mixed environments, ideally it works best when both ends support device lock, but you can use it. If you lock a receiver, it prevents changes to its subscriptions. A locked transmitter will prevent creating other flows. So that means if you're worried somebody's going to steal a multi-track of your famous artist show, put the lock feature on. It stops people just coming along with Dante controller, with Dante virtual sound card and just taking a recording. They won't be able to do that then. And you can mix lockable and unlockable devices, it's no problem. So we store these as XML files, and if anybody is into computer science, you can indeed open it and play with an XML editor if you want, if you really want to. So you could create a preset in XML, an offline preset maybe. It's still a very clunky way of doing things. We suggest that you use presets to save the state of a network so you can restore it to that state quickly. And of course we can save device names and the roles of devices as well. So we can quickly reconfigure a Dante network to do various different functions. If I'm using something like a multi-purpose hall, I can recall the patching by using different presets. So in order to capture a preset, you click the preset button, which is this little star. You select the devices that you want to capture and which parameters of the devices you wish to take as well. Now, generally, when I'm doing presets, I always select all of everything and save just a complete snapshot of the network, because we do have selective recall as well, which is very handy. And of course, we have this wonderful, unique feature where we can save the file to any folder on our PC, because no one's ever done that. You could, if you want to edit XML, feel free. It's very tedious, but you could do. Sorry? Yeah, it's XML, yeah.
Coding.
It's configuration. Yeah, potato, yeah. It depends. And then we have the selective recall. When we want to deploy a preset, it reads the XML file, and we have the preset device names here, and we can decide which device is the target device. So we can decide to push that to that device, and we could do it one at a time, or we could do a just general select all of both, and push everything across. And then hit apply, and it will sit there and churn through all those settings and check them, and it can take a couple of minutes to do that. One of the key features of Dante is also redundancy. So we can create redundant networks, so we can have two physically independent networks, a primary network and a secondary network. And audio flows on both the primary network and the secondary network all the time. There's no switchover. So if I destroy the primary network, I won't hear it. I won't hear any change, and the audio will keep going on the redundant devices. It'll be no problem. And the setup's completely automatic. So if I make a subscription on Dante Controller plugged into the primary network, the secondary network completely mirrors the primary network automatically. Otherwise, it wouldn't be a fully redundant system. So yeah, it completely mirrors that. And it's great for mission critical systems. So to set up redundancy, some top tips here. Set up the primary network first. Now the reason why I say this is because we need a separate set of cables and switches connected to the secondary ports. Now, some Dante devices have a labeled primary and labeled secondary port, but when they come out of the box, they're actually set to what we call switched mode, so that becomes a daisy chain, and actually both of those ports are primary. If you connect the primary to the secondary network, it's going to be a disaster. So personally, I always set the primary network up, and then I check every single device and make sure they're all in redundant mode. And then I plug in the secondary network because I know I'm going to be safe.